Hello everyone, welcome back to JDCodebase. This is the video number 34 of our LeetCode 75 study plan series. And today we are in the binary tree DFS section and we are solving the problem called the leaf similar tree, LeetCode number 872. And this one is really a clean problem. Once you understand what a leaf node is, the rest just fall into place. So let's get into it and read the problem statement first. Consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. For example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, 8. And two binary trees are considered leaf similar if their value sequence is same. Return true if and only if two given trees with head node root 1 and root 2 are leaf similar. So let me simplify this problem statement for you. We have the two binary trees and every binary tree has something called the leaf node. Now first of all, what is leaf node? A leaf node is like these 6, 7, 4, 9, 8 that has only root, means there is no child further, no left child, no right child, and it just sitting at the end of the branch. Like 6 has no left child, no right child. 7 again same. 4, 9, 8 same here. 6, 7, 4, 9, 8. Now if you collect all the leaf node of a tree from the left to right and means from this 6, 7, 4, or 9, 8 and you get what is called a leaf value sequence. The problem is asking you to both trees have the same leaf value sequence. Means for example, these are the two trees 3, 5, 1, 6, 7 and these are all these, and we have to find out the leaf node sequence. Like here I have 6, 7, 4, 9, 8, 6, 7, 4, 9, 8, and these they are the same. This pattern is same from left to right. If we read, the pattern is same, means the answer is true. They are leaf similar. If the sequence are different in any way, the answer is false. Like instead of 4 here, 3 comes, then the answer becomes false here. So simple enough, right? So let's see, like the question is, how do we collect all the leaf node from left to right? First of all, we use the DFS depth first search. We go as deep as possible on the left side first, then come back and go to right side. And this naturally gives us the leaves in the left to right order. And in the last problem, we already see the maximum depth of binary tree by using recursion. And same concept apply here. So if you did not watch that video till now, go and watch first, then again come here, because that video is the foundation of this problem. So this one is actually very important for this video. And for this approach, plan is like we have to write a helper function that takes a tree and collect all the its leaf value into an array. And we do this using a DFS. We go left first, then right. When we find a node with no children, we push its value into the array and call this helper function for both tree 1 and the second tree also, and we get the two arrays. And in last we compare the two arrays. If they have the different length, then return false. There is no need to check. If they any value at the same position is different, then return false, otherwise return true. And that is the whole plan for this question. So let me write the code so you can easily understand. Let me first delete this and make this space. Yes. So I have this main function. It has root 1 and root 2, means the two trees comes here. So let me write the helper function first. Function and get leaves, and it's take a node and a array. Then means we are defining a helper function called the get leaves, and it takes the two things: the current node we are visiting and the array. which is the array where we will collect all the leaf values, and we pass the array in from outside, so both calls share the same array for their own tree. Now first we have to write the base case. If node is the null, then return simply, there is no need to return anything. Means this is our base case. If the node does not exist, meaning we went past a leaf and there is nothing to do, we just return this. Also handle the case where a tree is completely empty, so for that also it's helpful. Now write if node dot left and node operator node dot right. Means if the both values are null, like left child null, right child null, then null, I am using the node operator, it becomes true, and means there is no means we check a leaf, if a node has no left child, no right child, and it is a leaf node, then so we push its value into an array dot push the node dot value, and then we return from it return just normally, and means there is nothing more to explore from a leaf. And we again call this, after this we again call get leaves function for node dot left and pass this array, and get leaves node dot right and pass this array. Means if the node is not a leaf, we go deeper. First we go left side, then we go right side, and this is the DFS part. We going left first, we ensure that we collect all leaves from left to right, which is exactly what the problem asks. Let me explain here. Like I have this root, and then again in the left side I have this 5. This 5 is again a root node, then it has the left side and the right side, so we again go to 6. We check the 6 as the values had a left and right child has the null value, so if they have the null value, then we push array dot push node dot value, means we push the 6 here and we return. Then we get the leaf, means there is no further, so we again comes here, we check for 2. 2 has the left and right side, again come here 7, then 7 check here, then null, then we push the 7 here, again go to 2 and come at the 4 here, now right side, again null and null, then we push the 4 here, then we go back to the 5, then 3, then comes to the 1. Now 1 to 9, and 9 we check further value null both the left and right child, so we push the 9 here, and we again go back to 1 and then 1 to 8, so we check again and push the value 8 in this, and same, and these go back value by using this node dot left and node dot right, we just use this. Now let's write the main function here, and this leaf similar is our main function. It takes the 2 roots of the both trees. Let array 1 is an empty, and let array 2 is also an empty array. That means we create the 2 empty arrays. ARR1 will hold leaf of tree 1 and ARR2 will hold the leaves of tree 2, and just call these function get leaves, sorry spelling mistake, and I just call the root 1 and pass this array, and get leaves root 2 array of 2, and use here the 1. So I get all the means I get the values all the leaves into the array 1 and array 2, means we call our helper function for each tree. After these 2 lines run, array 1 has all the leaves value of tree 1 in the left to right order, and array 2 has all the leaf value of tree 2 in the left to right order. Now we have to check if array1 dot length is not equal to array2 dot length, then we return false. And means we, before we compare the values, we just check their length. Maybe there is a length different, arrays have different length, they cannot possibly be equal, they cannot be possibly be equal, so we return the false immediately. There is no need to use the for loop here. Then if the returns false immediately, means if it's not if they are equal, then we have to start a for loop for let I equal to 0, I smaller than array1 dot length I plus plus, and we check if arr1 of I is not equal to arr of 2 of I, then return false immediately. Means we go through both the arrays at the same time using the index I, and each position we check if the value exactly match or not. If we find even one mismatch, and we return false right away and no need to check the rest further. And in last we have to just return true here. If we made it through the entire loop without returning the false, that means every value match, so we return true and the two trees are leaf similar. So let me run the code. And yes, it accepted. Let's try to submit the solution. And yes, it's accepted all the test cases and our solution is working. And that's it for full solution for leaf similar tree. And the key idea here is simple: collect the leaf node using the DFS. This DFS is depth first search. It's most important topic in the data structure and algorithm. And then compare the two sequences. And once you see it that way, the code almost writes itself. If this video helped you, please give it a thumbs up. It really helps the channel grow. Subscribe to JDCodebase if you have not already, so you do not miss the next video in the series. And drop your question in the comment below. I read every single one. See you in the next video.